This will be for the con exercise, identify function transformations. All right, in all of these, I believe F will be the original and G will be the transformation. F will be the solid blue line and G will be the dotted red line. All right, so that's probably the same for all of them. Anyhow, let's look at what we have here. If you look at the dashed line compared to the blue line, to me, it looks like it is horizontally compressed. In other words, they took the original blue graph and they basically compressed it horizontally from left to right. All right, if you remember from the horizontal exercise, the notes at the beginning, to make it horizontally compressed, you take f of x and you multiply the x by a constant k. All right, and in order for it to be compressed, k is going to be greater than 1. Okay, remember it's the opposite for vertical and horizontal. So for the vertical one, if k is greater than 1, it's actually vertically stretched. But for the horizontal one, when it's horizontally compressed, k is greater than 1. Or I said that backwards. When k is greater than 1, it's horizontally compressed. All right, so it's going to be something f of k times x, where k is less than 1, and k should be, k is greater than 1. So let's take a look at our options. All right, let's see. So the only one where k is greater than 1 is answer D. All right, the other one's a fraction, and these two are negatives. And just real quick, just to go over it, the negative, if you negate the x, it does a reflection over the y-axis. So in other words, you take an x value, and you take an x value, let's say at -4, at +4, and then you make the same y value at -4. So if you do f of x compared to f of -x, it moves the point over there to the other side of the y-axis. All right, but we don't have that here. The only thing we have here is a horizontal compression. So that is definitely answer D. If it were 1/3 x, it will be horizontally stretched. Once again, G is the transformation of F. F is solid blue. G is the dotted red line. And what is the formula of G in terms of F? Now for these, it may help to look at the answer choices first. And you notice all of these are f of x times a constant. All right. So when it's horizontally stretched, the x itself is multiplied by a constant. And that's not the case with any of these. The number is outside the f of x. So all of these answers are in the form of k times f of x. All right, and when you have that, that is always going to be a vertical stretch or compression. All right, it's going to be vertically stretched or compressed because k is multiplied by f of x. And remember, for the vertical, it's more simple. Okay, if k is greater than 1, it's going to be a vertical stretch. And if k is bound by 1 and 0, it's going to be compressed. All right, so we just have to see what the graph is and then narrow it down to one of these. All right, so if this was vertically stretched, it would be more narrow than the blue graph. It would be more narrow like so, but that's not what we have. Okay, we can see it's more wide. Okay, so that is vertically compressed, not vertically stretched. All right, and being that it's vertically compressed, the K is going to be between 1 and 0. All right, the only way it would be a negative if there were a reflection over the x-axis. Okay, remember, if you take f of x and you change that to negative f of x, you're multiplying all the y values by a negative number. So any y value over here would become over here, and the x-axis would be a mirror. Okay, but that's not the case here. We don't have any reflection. This is just simply a vertical compression. All right, and the vertical compression, the K is going to be between 0 and 1. Answer A. All right, you really have to look through your notes that I made for the other exercises on these. All right, once again, blue is the original, red dotted line is the transformation. Okay, F is the original, G is the transformation. What is G in terms of F? All right, on A and C, we're adding or subtracting 6. So in other words, that shifts it up or down by 6. And then on B and D, we're adding or subtracting 6 inside the parentheses, so that will shift it left or right by 6. So in other words, it's either going to be shifted up, down, right, or left based on the choices. Okay, pretty simple. So clearly, if you look at the vertex point of this parabola, all right, the y-coordinate here is between 4 and 2, so that's a 3. And the y-coordinate here is between -2 and -4, so that's going to be a -3. So it went down from 3 to -3. So obviously it shifted down by 6 units. Okay, so you just take the original f of x and subtract 6 from that. All right, last one. The dotted line is G. The blue line is F. What is the formula of G in terms of F? All right, again, easy one because it's either shifting up, down, right, or left. So we can clearly see if you compare this point here to this point right here, this is at -3, and this one here is at +3. So the dotted line shifted to the right by 6 units. Now remember, for right, left, it's actually the opposite. Okay, you would think it's +6, but it's actually going to be -6 inside the parentheses. Okay, so that's going to be f of x -6. All right, last one. This is the toughest one. Now, if you'll notice, the original in blue, it is almost a reflection over the y-axis. So if this one in blue was reflected, instead of being at +2, it would be at -2, and it would basically be like that. Okay? But that's not the only thing that happened here. We can see, I'll write reflect over y-axis first. So since this is reflected over the y-axis, f of x becomes f of -x. Okay, we basically took each x coordinate and changed the sign. So if it was like f of 6, it becomes the same y coordinate for f of -6, and it reflects over the y-axis. Now, the other characteristic of this dotted graph, if you see this one in blue here compared to the dotted graph in red, this one in red is actually stretched horizontally. And recall, for the horizontal stretch, the x the x's are multiplied by a constant k, okay? And when it's stretched horizontally, k is going to be between 0 and 1, okay? Remember, it's the opposite. For the vertical stretch, k is greater than 1, but for the horizontal stretch, k is between 0 and 1. Okay, so we have to combine these two. It's going to be f of negative x, but the k is going to be between 0 and 1. So it's going to be like negative 1/3 or negative 1/2, something like that. All right, looking at the answer choices, answer A is negative 1/2. B still has the reflection, but it's the k is greater than 1, so that would make it horizontally compressed. And these are multiplied by f of x on the outside, not inside the parentheses. So these are vertical stretches. So it's answer A.